I got Will here, William Squires, who's the CEO of Microcosmos, behind Subnet 1 and a few other subnets on Bittensor.
Yeah, so thanks for having me, Jake. So we're a little bit like a stealth silent team right now, but my partner Crux and I have been getting ready for a big bang launch in the next few weeks. So hopefully you're going to be able to see a little bit about what we're doing and what we have planned for the next few months. So very excited to be here out in the beautiful Bittensor HQ.
Yeah, absolutely. And we also have Philanthrope on the stage. Philanthrope is the subnet owner on 21, File Tao. Is it 21? I'm just getting my numbers a bit messed up here.
Yes, sir. 21.
Indeed. Okay. Well, it's been an interesting week. Definitely a weekend and Easter. We got a fair amount of FUD from Eric Wall and Martin Shkreli and other Twitter people. And I thought that I would take a moment to actually read the tweet. Usually on Twitter, I don't really respond in detail to FUD because it's a kind of a waste of time. I did a little bit over the weekend, but I wanted to read out just the whole tweet itself and go through a little bit about what was in it. It's quite hilarious. I like Eric Wall. He's a Bitcoin maximalist, and I respect that. And he's actually a really a good analyst. This was just really quite a hack job. So I'll read it out. So the uselessness of Tao is truly spectacular. $10 billion market cap for an AI coin? Go check it out. What does it actually do? It runs a bunch of subnets, okay? What are these subnets? Let's go check out subnet 1. Okay, so text prompting, cool. That's easy enough to understand. But what actually is going on here? Let's check the docs. Okay, so miners on the subnet run two different LMs, Zephyr and WikiAgent. Okay, I'm just going to stop right there because the level of misunderstanding from Eric Wall starts really, really early in this tweet at that line. And I was trying to write a rebuttal Medium post for this tweet. And I realized it's just as difficult to refute something that is true as it is to refute something that is completely diverged from the truth, let's say. These concepts are difficult. This statement, so miners run two different LLMs, Zephyr and WikiAgent. Anybody who's mining knows that the neuron miners that people run are not, the ones that are written by the subnet owners are not the ones that people run in practice. So Zephyr and WikiAgent for Subnet 1 are literally just examples. They're example neurons. They're not, it's like a tutorial. It'd be a little bit like if someone looked at the substrate docs for Polkadot and said, oh, wow, look, there's only a template substrate chain that anybody can run. It's completely unusable. Literally that ridiculous. So within the first 5 or so sentences of this quote unquote hit piece, he says something that is so completely far from the truth that it's a little bit difficult to go on, but I will go forward. So most of all just run Zephyr, the base model. The idea is very simple. You send in a prompt, the miners will run the LLM and respond to you like ChatGPT. Miners who do this are rewarded with Tao tokens. This is how Tao tokens are brought into existence. Okay, good. Well done, Eric. But it does mean that for every prompt, you have literally thousands of miners who will complete the exact same task redundantly. So this is again where he goes completely diverges from the truth because of the fact that there's a separation between validation in Bittensor and inference. And for most people, it may be difficult to understand how validation systems work because effectively what we're building are loss landscapes from a machine learning perspective. And in a loss landscape, you construct the landscape simply so that the neural network can climb it. So you build an objective function that the neural network is going to optimize itself against. It's the same thing in Bittensor. There's a validation landscape which is created by the validators, and then the miners climb that validation or that reward landscape to maximize their performance so that they can be used. Not the loss landscape is not actually the product of the subnet, and this was a complete divergence from what's true. So on subnet 1, it's true that validators do query 1,024 miners redundantly, but only so they can create a validation landscape which is fair and accurately measured, so that we can reduce the error in the reward function for the miners to climb. When inference requests actually go through the subnet, at no point do we query 1,000 miners. So that's the second item. There's a third point that he makes in his, let's say, takedown, where he says, in the present version, the validators produce one or more reference answers, which all miners' responses are compared to. Those which are most similar to the reference answer will attain the highest reward and ultimately gain the most incentive. It's a quote pulled out of context, because if anybody were to read the documentation, they would understand that the reference answers are constructed by the validators by taking context from the database and producing an asymmetric validation system where they have context the miners don't have and can produce a question and an answer from the context that a miner can only produce by doing an inverse function and going to get the items from their database and injecting them into the context window of whatever machine learning model they are running. The idea that if this were just the case, if it were as Eric Wall described, it would be ridiculous. There would be no point to do a simple one-to-one comparison if we weren't trying to just improve speed. Anyway, so this exploded, and obviously there was Martin Shkreli came in, and he latched onto this, and then we had to explain to him what is going on. Anyways, these things are difficult to understand, and so it is understandable how Martin and Eric were not able to understand how these validation systems work. But in some sense, if people can't understand them, those people shouldn't be here. And we should shake people that can't understand things or are disingenuously attempting to FUD us when they haven't done that initial work. So it's not a bad thing. And FUD really can be thought of as a way of making us stronger as a community. So it was actually quite beautiful to see the response. So we made this funny like meme, which I'm going to share my entire screen here, and I'm going to find Wolf's. Here it is. Let's find this key. So there's Eric Wall showing up with his FUD campaign. Send it to 0. We have Martin coming in with his engineers, not understanding. He's going to short the price. What is this? This is a dip for ants.
The price collapses.
The price collapses. I mean, well, technically the price was in a correction phase anyways. So he tried to take credit for that. But hilariously, well, we showed up in force. The Bittensor community showed up in force. We got Mog Machine. He came into the spaces, Neural Internet, Const. We had some more people. We had Crux coming in, dropping some fact bombs, beat with facts and logic. And Martin actually, he ended up shorting the price, or said he was shorting the price at literally the lowest point. I don't like speaking too much about price, because I think it's not the best, the most accurate signal, but this one was just fun. I really enjoyed this particular moment. Maybe he'll lose so much money and get wrecked so bad he'll go back to jail. Anyways, so that's that. I won't share my screen anymore. I just thought that was quite funny. And it's a good segue though, because people don't understand these concepts. They're very difficult to understand, but the best people to explain them are those people that truly are making incentives work on Bittensor. And maybe there's no better example than Philanthrope, who's running File Tao on 21. Perfect example of where we can use incentives to lower cost. And so that's the beginning of this conversation. So anyways, Philanthrope, you've already on the stage, but welcome to the stage, and let's talk File Tao.
Awesome. Thanks, Const. Appreciate you having me on. Really looking forward to this. I think it's good to keep in mind that, what we're doing here is really novel and experimental. And, I think it's convoluted and difficult to understand. And I think part of our job is to try to help people understand in as simple terms as possible. And I think it's quite a challenge for us. And it's encouraging, because I think it means we're on the right track. If there's significant friction from people who are struggling to understand, then it's a sign that we're, I think, heading in the right direction.
Exactly. And in terms of direction, usually subnets that are working really well have a very specific, let's say, digital commodity or metric that they are pushing. What is that metric for File Tao?
Yeah, that's somewhat different to some of the other subnets, like if you're inference, like with subnet 1, which is its own, very, I think, difficult problem to solve. This is a little bit more clear cut in the sense, it's either you have the data, you don't have the data. It's a little more difficult to fudge. So the commodity product is really certainty, cryptographic certainty around data integrity. Is that data available? Has it been available for a provable period of time? And can we retrieve that data at will? And the reward mechanism for 21 is designed in a way where you want to be able to have the miners store the data, be able to retrieve that data, but then continuously prove to the validators that they are actually still storing that data. They didn't offload it. They didn't do any tricks where then they can recompute it and get it back if they need to, and kind of pretend that they're having X amount of storage. And so I think the reward mechanism is also dynamic in the sense where you want to be able to create that kind of stability in the miner set. So there isn't a significant amount of churn in those who are performing very well, while still allowing it to be fair and open in a way that allows people to really participate. So if you're a new miner, still kind of having that path to ascendancy, so that you are able to actually participate in a meaningful way, just like, we really have in any other democratic kind of meritocratic system. So it's very interesting from this perspective of, what you were mentioning about, the validation mechanism with, for example, subnet 1, where, the inference isn't happening, 10, 24 times. And similar to FileTao, there's essentially a group of miners that are queried every step, and kind of asks this question, do you still have this data that you said that you have and you claimed? And are you able to show me a cryptographic proof that that's actually the case? And then the validators essentially can do some asymmetric computation so that it's very light on the validator side. But then the miner essentially has to be continuously storing that data. Otherwise, they're going to be disincentivized and really punished for missing challenges, failing to retrieve data, or failing to store data in the first place. So it's in that way, it's actually very amenable to kind of what FileCoin has, but surprisingly, it may be surprising to see, it's actually a much simpler mechanism in the sense that you don't have to do this several layered sectoring approach that they have, which is very cryptographically secure, but unfortunately is, in my opinion, unnecessarily complicated and ends up being relatively inefficient. And so what they're having to do now is create extra layer caching layers where they have to unseal the data and then have it ready. And so I think they're in a way kind of scrambling to try to figure out how do we actually turn this into a usable product that, doesn't take 2 hours to actually get your data out of it. So really the approach, we took with FileTao was to say, okay, how can we get that same kind of integrity and consistency and verifiable data integrity, but actually have the data be retrievable in a reasonable amount of time?
And Jason, Will, I believe, has a question for you here on that note.
Yeah, absolutely.
As you're speaking, Jason, it kind of, one of the things that really comes to mind to me from both the conversation shorts you've had today, Subnet 1 and FileTao, is now everything you've just spoken about is about having something reliable, something secure, something you can check in with to make sure it works, something that's quick, but also something lean from a market economics perspective. And when you're writing the rules of the system, it's almost analogous to like the car industry. People buy Volkswagens or BMWs because they're reliable and secure. You take them in for an MOT once a year or whatever your different global version of checking your car tires and pressures is. You don't check the car runs before you get in every day, but you have this trust through the sort of validation processes the industry surrounds you with. That's what makes it work. And, the analogy we had of Subnet 1 earlier, where I was saying it's sort of, you're setting the rules and everybody's running the same cars. It's kind of more like F1. Actually, what's happening is there's a rule set for the cars and everybody's tuning them up to beat the competition within these fine grains of parameters. And, on Subnet 1, we're getting more out of the base models than anybody has ever got. The miners are doing incredible things. But I think the interesting point about FileTao is how using that market incentive function, that sort of economic function to make it as lean as possible, as opposed to perhaps the more technical implementation that FileCoin have sort of screwed them into, has led to really, really good results. And, ultimately sort of competitive scale with FileCoin, where the implementation cost of yourself and your team is a fraction of what they've done just by using that market incentive structure.
Yes, absolutely. I mean, the irony is, as this scales, and with the way that Bittensor is designed and set up, is that we're actually able to significantly undercut many centralized even service providers that you would assume would be able to offer very cheap storage and say, well, we're paying for this guarantee, but we're actually able to do the same kind of thing but do it at a fraction of the cost. And without getting too technically in the weeds, one of the major things that's different about FileTao versus FileCoin is that FileTao's mechanism essentially leverages those two things, market structure dynamics, but also randomness, so that the miners are essentially forced to store all the data, not because we have this brute force approach with layered sectoring like FileCoin has, but with random challenges that says, hey, if you have 10 pieces of data and then I randomly choose one of them every so often, you're going to have to store all of that data, because if you somehow randomly get a challenge for data that you've offloaded or deleted, then you're going to get penalized. And so you really don't need to have, I think, an overcomplicated mechanism to have this kind of security. And it's kind of ironic that, typically the more complicated things are, the more difficult they are to maintain, the more inefficient they get. And so, in my opinion, the simpler the better, and being able to model in a way kind of natural market dynamics is going to be the best way to go. So just want to take a second and maybe, if people aren't familiar with FileTao, kind of explain very briefly how the mechanism works and how it's different from FileCoin. And essentially it does work in a multi-layered proof system where you have the validator sends these queries to the miners to say, hey, I want to store a piece of data. Then if you do store this piece of data, then you will be able to send a proof back that says, hey, I received this piece of data and I want to be able to cryptographically verify that this was done appropriately. And so the validator receives that proof and it's based on what's called a Peterson commitment. So it's a very low data way of doing proofs, where the validator sends a set of initialization parameters, which are essentially the setup for an elliptic curve, which in this case is a particular one, but can be swapped out for any other, just like Bitcoin uses SEP 256K. This is P256. And this curve is used as a starting point to where the miner has to create a Peterson commitment along this curve path, using a random seed that the validator sends to the miner, along with the data, the challenge data that was sent along. And then the miner computes this Peterson commitment, thinking about it as an envelope that you put this piece of secret data, this point on the curve that was computed, you send that back to the validator. The validator can then unwrap this envelope and say, oh, okay, I have this new point. I'm going to do a simple multiplication of the initial point I received and then the end point, and then be able to return that, improve that, so then they can say, oh, the miner, yes, they did store this piece of data. So now the miner ends up having, the validator ends up having the index of, say miner 15 has this particular piece of data, and I use this particular seed that they had stored on it. And so then you can use that to do future challenges. So this creates an iterative process where over time, miner validators build up an index of which miners have what data, and then they can continuously challenge them throughout the validation mechanism process at every step. And so you only have to challenge a subset of miners randomly at any given point. And after a period of time, you'll be able to create enough coverage where you'll eventually be able to validate all of the data on the network, essentially over so many epochs. And then when you want to retrieve data, it's as simple as verifying that, oh, did you commit to this data again before you sent it back, which is a very light proof. The miner sends the proof and the data back to the validator, and then it can be serviced to whatever endpoint without any complex sealing or unsealing, like in FileCoin. I see there's some questions here. If validator A stores something on a miner, can validator B access it? This is a good question. And the answer is no, because each validator is siloed in the sense that it has its own index, because this is actually a security issue. If there's a global shared state, then there's essentially opens up an attack vector for miner validator collusion. And so you can then do data poisoning, essentially being able to fake data that miners either have or don't have, and then would essentially make it so that other validators can cheat or other miners can cheat. So this actually opens up a market opportunity for validators to be able to create endpoints, so that if you want to work with a particular validator, they can create API access into their validator, which then creates a market for a level of trust across the validator set. So if you want to, work with, let's say Keith's validator, or with Roundtable 21 or Polychain, DCG, Foundry, any of these validators, they can then spin up their own endpoints and have their own services built on top. So it does create this bespoke market structure. Yes. So, and this is the other concern about how do you have data persistence across the network, is all of this data is public, meaning the validators that have a list of their miner statistics. If a miner gets deregistered, it's always recoverable from WAND B data. There's also, we're working on actually a dashboard, which would be able to have all of the validator set data included in it. So then anybody can go publicly verify which miners have what hashes without ever exposing the data itself. So it is recoverable. All right. It seems like we're back.
I think we're back. Just cut out randomly here. Anyways, but we had some questions for you, Philanthrope. It's very useful for people to understand validation systems at the core, as if you were explaining it to a 5-year-old, EL5, but in pseudocode.
Yeah. So I'd say the ELI5 version is, I want you to be able to prove, okay, if I give you something of mine, how am I going to prove that you still have it without you giving it back to me and being able to check it back and forth? I just want you to disclose a tiny piece of it. Maybe, send me a picture of it. And that picture has some cryptographic proof associated with it that gives me the security and the confidence that you actually still have that. Kind of like having someone, if you take someone hostage or someone's taken hostage and they say, hey, just let me hear their voice so I know they're okay. You want to be able to actually validate that they're still over there on the other end of the phone and they're still alive. And that's essentially kind of what's going on in a nutshell, is being able to have this lightweight proof without you actually having to physically go over there and verify it yourself, but something that will create confidence so that you're willing to essentially believe that person on the other end of the phone. And you keep doing this over and over again, multiple times across all of the miner set. And validators are independently doing this so that you have multiple people publicly validating all of this data continuously. Is it possible, maybe I can share my screen here. We actually have this dashboard that is in progress right now. It's not complete yet, but it's something that we've been working on, and I think would be a good analogy to show here. If I could find yes, here we go. So this is just for one validator. This is actually on the foundation validator right now. And so this is something I want to be working and partnering. We're going to work with other validators to get this data across the entire subnet. But you can track things publicly now, and you can see exactly what all the miners' tiers are, how much storage capacity they have available, and have a leaderboard of what their incentives are. And if you want to be able to look at a particular hotkey, you can select that. But the interesting thing here is right now we have a current capacity of almost 2.5 exabytes, which we were just talking about this right before the call, that this is actually about half of the current storage usage of FileCoin. And so we're, in a place where we really are able to, I think, as we grow and expand the subnet, quickly catching up to where FileCoin already is. And it's a matter of, time really before I think we're able to double this capacity and get to exactly where they are already. There's a fun analogy we came up with earlier, just before this, that, if you put this in terms of floppy disks, the capacity of File Tao if you stretch those floppy disks out along the equator, it would wrap around the Earth 4 times over. So let's see here. Let me back up a little bit. So, all right. This will be up and available in the next week. We're going to show this to everybody. I'm going to partner with other validators to get all that data and make it publicly available. So there's another place to go, not just on WANDB, which is where all this data currently is. So this is kind of where we're going, where we're heading. We really want to be able to offer this free service, essentially, and being able to store data on the network so that participants are able to store not only from Bittensor users, but also externally. And there's a front end that is going to be coming out shortly. But the real advantage here, what we really want to be focusing on, is how this is one of these modular building blocks that will allow Bittensor to continuously evolve and create that flywheel effect. Because right now, while we are decentralized, the problem is we're still reliant on several centralized actors, whether it's Hugging Face if we're sending model weights there, or AWS for S3 buckets, or even chain storage data could be stored. I mean, so this is one of the real, I think, ubiquitous use cases. We'll be able to store whatever we want, so that structured data, unstructured data, model weights, any of these other digital commodity products that subnets will produce could be stored on a Bittensor native subnet, which then will allow this seamless integration at the API level, but also externally so that it can act as almost an internal IPFS for Bittensor. And that's actually one of the things that we're very focused on is maintaining this feature parity, where whenever you store a piece of data on FileTao, right now it creates a content identifier hash, which is just like IPFS, and that IPFS hash is essentially your link to that data and can be accessible from anywhere. So it seems like we're still having technical difficulties. So I'm just going to go ahead and kind of continue from where we are, and then hopefully they'll be able to come back. But what does Bittensor need to be able to allow us to operate completely independently? And one of these things is storage, and that's one of the reasons why we're so focused on building this out, because once we have this in place and it's completely available to all subnets, and it already is, there's an API that is queryable, send requests directly to the foundation validator endpoint on subnet 21, and that will store and index the data there, and will be accessible by any content identifiers or hashes that are returned there. So if you have a piece of data, whether it's structured data or unstructured data, model weights, you're able to effectively use that as temporary or more permanent storage. But right now, it's pretty safe to say that you want to make sure that you don't want to store your wedding photos right now, because there is kind of a TTL, unfortunately. So I see we got Shib on the call. Can we hear you okay, Shib?
Yeah, okay, awesome. Yeah, and I'm just joining in. I think Const is having some issues on his end, so I'm here to, MC for you. I got you.
Beautiful. Yeah, I want to make sure we're covering all the bases here, so I just kind of am going ahead a little bit. Is there a roadmap for what the rest of what Const wanted to discuss, so we can address that?
It's really more about your subnet what it is that you're building, right? So I think that's what people want to hear about, and I think that's going to be really helpful for even me to understand just how much work has gone into the technicalities, right? Like the validation mechanism itself, for example. Sorry if I missed it. I'm not sure if we covered it in depth quite yet, but I think people would want to hear about how you're validating all of this.
Sure. Yeah. So I want to make sure that I'm not kind of going too deep into the weeds, but I want to maybe start at a very high level. And we did talk a little bit about it, but there's several components to it. And it's a 3-tiered mechanism, at least. So there's 3 levels. It's essentially cryptographically, how do you validate that someone has something or not? And then how do you reward for that behavior? So if someone's doing well, how do you create that incentive landscape and appropriately keep miners who have been performing well rewarded proportionally to the amount of value that they've been contributing to the network? And so, it's evolved over time. And I think the initial proof system came from an inspiration from FileCoin, actually, and spent a lot of time learning their white papers, understanding how their code is structured, and then figuring out what kind of proof system they use. And I alluded to this earlier, that it's actually a little bit, I think they go the extra mile and really make sure that it's absolutely airtight. And while it's very important to do this, creates a lot of kind of overhead and unfortunately inefficiencies, where they take quite a long time to retrieve that data. You have to create this sectoring and unsectoring, which really means they actually redundantly store quite a lot of data that really is unnecessary. So the difference in File Tao, what ends up happening is when you store a piece of data, the validator is able to say, okay, prove to me using a Peterson commitment, which is a very asymmetric form of computation, where the miner has to create essentially a series of proofs by committing to that data using a series of Peterson commitments that chunks the data into multiple chunks. Each chunk is then committed to as a point along this elliptic curve, then creates a Merkle tree up to a random index that the validator selects for that particular data. and then sends the response back. Essentially, the Merkle proof creates the Merkle root and then the proof index, sends that back to the validator. And then the validator is able to very quickly and very efficiently evaluate whether or not that data was actually stored. And this involves using random seeds. This involves being able to continuously validate that using a series of chained hash commitments. So once there's an initial store request that's received, and that miner proves to the validator that it actually has stored that appropriately, now that miner can be requeried multiple times over and over again to create this what FileCoin calls their proof of spacetime. And they do it using this, like I said, very complicated sectoring and proof of replication approach. But it can be approximated very easily by simply creating a chain of hashes that uses a random seed from a previous time step, the data that the miner supposedly still has at challenge time, and then a new random seed that the validator provides at the challenge time. So if you have these three pieces, you can create this current hash, which says, okay, well then if I've been able to prove that you had this data at the previous time step and you have this data at the current time step, you can infer that the chain continuously unbroken means that the miner has indeed stored that data for the history since when it was first stored. Because at any point along this series of challenge proofs, if that's broken, then you know that there's been either a failed challenge, the miner stopped storing the data for a period of time, or they attempted to fudge something by maybe swapping the data or having a different random seed that was used previously. So how this works in practice is then you can have a decent amount, a probabilistic proof, essentially, that 99.999% chance that the miner has been storing that data the entire time without doing this multiple proofs of replication like FileCoin. So it simplifies it quite significantly while allowing it to be very efficient and then have on-demand and immediate retrieval of that data by simply using this chained series of hash commitments. And one of the next steps of where we're going with this is actually being able to do this on chain using the metadata commitment scheme so that you could send a very light proof that's essentially a hash, several bytes, to the chain, and then anyone, even if you're a validator or not a validator, can look at the chain and go, I have this particular set of, the miner has proven that they've had this data for any period of time, and then could retrieve it whether or not you're a validator. And so this is, on the roadmap for us, is to be able to open it up so that validators are not the only ones who can retrieve data from miners, so long as they have the ability to access the miner endpoints. And that's where, another layer of this is going to come in, is being able to put 5.3 erasure coding on miners and having the ability for them to submit retrieve documents directly from the miners rather than having this pass through of the validators to be even more performant over time. But that's maybe getting a little ahead of ourselves. Where we are currently is this proof system using chained hash commitments, using a Merkle proof, and using the Peterson commitments, this kind of three-layered approach, has a continual evaluation across all of the miners on the subnet by all validators. And when you want to retrieve a piece of data, the validator essentially checks that series of chained hashes and ensures that it's correct and challenges the miner one last time to commit to that data using this Peterson commitment scheme, and then retrieves that data for the end user. And this is what I was alluding to earlier, that if you run a validator and you have an API node, you are able to essentially build on top of that API to be able to monetize it however you want. And so this is one of the benefits of having kind of this approach of having each validator have its own index, is then you can have private or proprietary data that's stored on the network. Because unfortunately, you wouldn't want private data to be accessible to miners, but what we do is automatically encrypt all of the data on the network. So miners never know what they're receiving. They have no way of being able to tell if it's a challenge piece of data or if it's a client or user data. And this intermingling creates a really robust mechanism where they have to store everything because they really just can't tell. And so if you're a validator and you're running an API and you want to store proprietary data on File Tao, you're able to do that comfortably because you can encrypt it at the local level that using Bittensor keys. If you have a Bittensor wallet and you encrypt your data using the Bittensor wallet within File Tao, then you're the only person that can ever decrypt that data. The validators can't decrypt it. They don't even know what's in it. And then the miners will never be able to decrypt it or know what's in it. So I think this opens up quite a lot of use cases for that, I think traditionally has been poo-pooed in the decentralized world is because you're saying, well, if I'm going to put my data on a decentralized network, then it's going to be public, and I don't want my data to be public. But the thing is, because it's double encrypted, there's absolutely no way of backing this out unless you have the original private keys that encrypted that data. So I think we're going to be able to really expand the use cases here, whether it's for other subnets, storing their data that's either public or proprietary, storing external client user data that also could be proprietary. And then people can create their own marketplaces essentially on top of File Tao because the underlying protocol is agnostic to whatever people are storing on it. And so you're able essentially to have the utility of something like FileCoin, but at a fraction of the cost. I mean, it's essentially free at this point because it's not currently monetized. I mean, the chain supports the miners to be able to run their infrastructure. It's quite light. Also on the validator side, there's no GPU required. So it's very easy to spin up a node. It's very straightforward. And, at a point where we're reaching this critical mass of, we're only several updates away from it being accessible from the outside world with a front end that connects directly to the validators on the subnet. And so the validators are able to store whatever they want. And this freedom is going to allow for people to create their own kind of bespoke commodity markets on top of File Tao.
Awesome. I'm just trying to check, is there any questions from the audience as we go? Because I don't want to kind of skip anybody. Is FileTao currently only using FileCoin to store all their data? Are we ever an option for storing data?
Is FileTao only using FileCoin? Oh, FileTao doesn't use FileCoin. So to be very clear, FileTao is inspired by FileCoin in the validation mechanism, but makes several improvements on it and efficiency gains without having to, extend the redundancy like FileCoin does. But actually, we don't even have a relationship or connect with FileCoin at all. So just to be very clear, these are all decentralized miners. We don't know who they are. They could be anyone to spin up a node and say, hey, I want to be a miner on File Tao. All you have to do is register and then provide good service, and you will be rewarded. If people want to connect to these services and you're running a miner and you have a relationship with Arweave or FileCoin, I mean, that's up to you. We're agnostic. But the ethos is to be as decentralized as possible. So, basically, please don't use an Amazon S3 bucket because that would kind of defeat the purpose.
Really? I was going to use Dropbox. Is that going to work? Awesome. Yeah, actually, I have one question for you directly. Now, you're one of the sort of, let's say, native builders, right? One of the first few subnets on the system. Actually, all the subnets today are some of the first few subnets on the system. What was the weirdest thing? What was the hardest thing you had dealt with in building, besides putting together the incentives, of course?
Oh man, that's a good question. I think what's been interesting to me is that you have an idea, and you think, okay, how do I technically achieve this idea? And the initial question was, how do I create the cryptographic proof system to be able to validate data on the network? But actually, the weirdest thing wasn't that. That was it wasn't trivial, but it wasn't exactly the hardest thing that I've kind of dealt with. What was challenging and kind of weird was actually creating the reward landscape mechanism, where how do I actually get the miners to not only, prove that they have that data, but then reward them appropriately. And I want to make sure that it's fairly distributed. And, you have a proof system, that's great. But then what happens with miners who they provide good service, but then suddenly they get kicked out of the system and you don't know why. And then you go investigate and you say, aha, this bonding mechanism that I created is too rigid. I need to modify it and update it. And so going through and learning that it's actually kind of an iterative process, that you can't just say, oh, I'm going to bake this and forget it, but that actually, you have to be very responsive to the community and very understanding of how people are using the system and what their experience is. And so tweaking things like the reward mechanism to be more organic. So like in any, I'm thinking of academia, you have this system where we have a meritocracy. You go through school, you go through these levels of education. And supposedly as you ascend these levels, you achieve a greater competency and you are rewarded appropriately, for the knowledge and the work that you're providing at higher and higher levels. So, taking that kind of as inspiration, learning to adapt the mechanism to what already works in a meritocratic society. So if you provide a good service, then you should be rewarded. But at the same time, you don't want people to get complacent and say, well, I've achieved the pinnacle. I have a PhD. I don't have to do anything now. I can just rest. But actually you wanted to have a kind of downward pressure so that miners don't essentially rest on their laurels. So there is this negative incentive part to the mechanism that wasn't originally there, where, typically in many other subnets, if you don't fulfill a task, let's say it's an inference task for LLMs, usually the reward is just 0. And that makes sense, because if other people are inferencing and getting higher rewards than you, eventually you'll get pushed down the incentive curve and potentially deregistered. But here, it's kind of a more challenging problem, because let's say you do store some wedding photos on here. If somebody loses your wedding photos, you're going to be pissed. And it's very bad to lose data. And so, that's one of the adaptations, was to actually learn to actually negatively incentivize things, so that really creating a more targeted reward landscape that exactly carves out the kind of behavior we want to see, but allows people to still have that upward mobility in the class system, as it were, so that there isn't this kind of gating and grandfathering mechanism where people that were just there first are the ones that reign supreme, but that actually you have to continually be proving your worth to the network. Otherwise, you would be subject to getting down leveled, essentially. So this negative incentive mechanism is actually very necessary, so that it creates this kind of upward and downward mobility in the incentive mechanism.
That makes sense. Awesome.
All right.
Okay. So I'm going to help you wrap it up, because we should wrap this up in a nice little.
Yeah, beautiful.
Let's see. One question I had for you as well here about the subnet itself. Say 2-3 years from now, what do you anticipate the File Tao to be at? What's the pie in the sky for you guys?
Oh man, I would say that it moving in stepping stones. I would really like it to be kind of the de facto storage platform for the Bittensor ecosystem, so that if you have a series of language models or machine learning weights, you would be able to store them comfortably there. If you want to store chain history data, be able to store that there. Any kind of structured or unstructured data, so that we can create this flywheel effect within Bittensor to allow for less reliance on centralized actors, whether it's Hugging Face or whether it's Amazon or GCP. So I think that would be step one. And then, step two, the kind of pie in the sky would be, this could be something that extends beyond, so that other people in decentralized AI and just crypto and in Web3 and also, mom and pops to be able to come and not have anything to do with crypto, not have to understand anything about what Bittensor is or how it works or wallets or any of that, but be able to use this just like Dropbox and be able to kind of store things comfortably and I think really address all of those use cases that people have and kind of fulfill this vision of kind of facilitating democratized intelligence, but being able to have this underlying commodity, which is storage, that we don't always think about because it's kind of in the background. It's like water to fish, it just surrounds you, and storage is this base feature that we need on the internet. But because it's so ubiquitous, it's not really thought about. But I want it to be like that. I want it to be so ubiquitous that you don't think about it, but you'd be using it under the hood, and that it'd be using Bittensor.
Right. It's kind of interesting, right? If you think about it, it's kind of like a car. Your storage is your gas tank, your data is your gas, and your model is really your engine, right? Your engine's only going to run as good as your data, and you can really have so much gas before your engine runs out of. You can only have so much data before your engine runs out of gas, right?
Yeah, you want to be able to take it as far as you want to go. If you want to go to Chicago or if you want to go to Ottawa or wherever your goals are, you're going to need that bandwidth and that energy, which it is kind of a form of energy that's kinetic, but at the time when you store it is feels static. But then when you want to go turn that into kinetic energy, but it's not there, you're going to fall short.
Awesome, cool. Thank you.
Cool.
Thanks.
Oh, I was going to thank you. Yeah, very, very appreciated. Thanks, guys, for having me on.
Awesome. Thanks,
Take care, everyone. Thanks.